say that there's only one example today, which sounds great, but what does that usually mean in calculus if we only have one example? It's a long one, and it is, but the good part is a lot of what we do in the notes for this problem, you can reuse in the homework tonight. So there's going to be some equations and some other things that I point out along the way that you can reuse. Okay, before we get to the example, I do want to tell you about some of our formulas that we're going to use for this problem. And you probably haven't worked on these for a while. This area of a semicircle is basically like half of a circle. You may have worked with this a little bit back in maybe even middle school or Algebra 1, but area of a semicircle is 1/2 pi r squared. Area of a semicircle, 1/2 pi r squared. Pi is just pi, but what do you think the r represents? Radius. Okay, I didn't put that up there because I figured you can remember that. Now, we're also going to need circumference of a semicircle. Circumference. Remember, area is the part on the inside. The circumference is the part on the outside, basically the distance around the semicircle. To find that, it's just pi times r. So pi times the radius. And the last one, and this is the one that I'm sure you can remember, the area of a rectangle. We did this a little bit on Friday. You just take length times width. That's the area of a rectangle. As you can see, we got a little bit about semicircles and a little bit about rectangles. So we're going to have both of those shapes involved in the example. We might also talk a little bit about the perimeter of a rectangle, which would be just adding up the sides, but I didn't really put that up here as a formula. All right, I'm going to give you the problem just kind of in pieces here. This is the first part, and it says a Norman window. I don't know if you know what that is or not, but I'll draw a picture. A Norman window is constructed by adjoining, putting together a semicircle to the top of a rectangle. A Norman window is constructed by adjoining a semicircle to the top of a rectangle. I have more things that I'm going to give you, but for now I want to just kind of show you what this is going to look like. And it wouldn't be a bad idea to put this down in your notes too, just so you know what we're working with. You could make your rectangle go either way. I usually just kind of do it long ways like that. There's my rectangle. So a Norman window is constructed by adjoining a semicircle, so like half of a circle, that's the best circle I've got, to the top of a rectangle. That's going to be a good start there for our Norman window. Alrighty, next part, this is actually it. This is the last thing to write down. Find the dimensions. Find the dimensions of the rectangular portion. Find the dimensions of the rectangular portion of the Norman window with maximum area I underlined that because that is a clue about how we're going to set up our equations. Remember, primary equation goes with the max or the min. So find the dimensions of the rectangular portion of the Norman window with maximum area if the total perimeter is 30 feet. Now, before we set up any of our equations or anything like that, I want to just kind of explain what all of this is talking about. When it says find the dimensions of the rectangular portion, I usually call this longer part the length. So I'm going to say let x equal the length of the, and I'm going to try and just put all this here, length of the rectangular portion. And I'll call this part the width of, and I'm just going to be lazy there and draw an arrow, width of the rectangular portion. That is the goal of this problem, to find out what the length is of the rectangular portion and to find out what the width is. Now, when it says that the total perimeter is 30 feet, let me explain that real quick. It's not talking about the perimeter of the rectangle. It's talking about the perimeter of this entire shape. So the distance around that part of the rectangle along with that part of the semicircle. The distance around that entire figure is 30 feet, not just the rectangle. Okay, so what I should probably do first is come up with my primary equation and my secondary. We are really just following the same steps that I gave you on Friday. We wrote down 3 or 4 steps on Friday. It's the same deal. The primary equation has to do with the part that's being maximized or minimized. In this case, it's being maximized. So the primary equation needs to represent the area of this figure. Now, we're not just talking about the area of the rectangle. We need the area of the rectangle plus the area of the semicircle. And I'm actually just going to write that out kind of in words first, just because I think this helps you see it a little bit better. I guess I could put the word of in there too. To find the area of the entire figure, we're going to have to take the area of the rectangle plus the area of the semicircle. It's like one of those I-step problems from a long time ago. You've got like a weird shape and you're supposed to find the area of the whole shape. Well, if you can find the area of that, and that, add them up, and it's the area of the whole thing. That's kind of what we're doing here, just one of them is a semicircle. Now, we need that area to be a maximum. So I know I'm going to set it equal to a max. All right, so let's start to fill in what we know. Area of a rectangle. We just talked about that. Area of a rectangle is length times width. So I'm going to put x times y for the area of the rectangle. Now, area of the semicircle. Maybe don't write all of this down right now because I'm going to do some erasing here in a second. But this was the formula that we had for the area of a semicircle. But I don't want to leave r as r in that formula. I want to actually put in what r is. So here for just a second, let me go a little bit further with this formula, and I guess you can kind of write these steps down in your notes too. But here in a second, I'll go back and fix what I have right here. The 1/2 is fine, the pi is fine, the square is fine, but I don't want to leave r as r. Let's actually figure out what the radius would be of this semicircle. Anybody know, based on what we have here, what expression could represent the radius? 1/2 x. This whole length is x. So if you want just half of that, the radius, and you could do it here or there, doesn't matter, the radius is actually 1/2 x. Now, I don't like how that looks. I want to keep going with that just a little bit. So the 1/2 pi is still out front. And think about what you get when you square a 1/2. When you square a 1/2, you get 1/4. And when you square x, you just get x squared. Now, I need to do one more thing here, and that is just kind of put all of this together. 1/2 times 1/4 is 1/8. And then I'm just going to leave pi x squared the way it is. So here in a second, and I'll make sure you get it copied down before I do this, but here in a second, I'm going to erase this 1/2 pi r squared, and I'm going to replace it with 1/8 pi x squared. That's just what we have on this problem, since the radius of our circle is 1/2 x. Okay, everybody got down the part in red. Might be helpful for your notes later on. I better keep it up there so I don't forget what it is. 1/2 pi, not 1/2, 1/8 pi x squared. Very good. And it still equals a max. So that right there is my primary equation. Took a little bit of work to get it, but there it is. Now the secondary equation, remember that equation is just based on all of the other information. Area was the maximum part, that was the primary. The other part that I know is right here in green. The total perimeter, not just perimeter of the rectangle, but perimeter of the whole thing, that total perimeter is 30 feet. Now, I'm going to sort of break this down like I did the last one. We're going to have to take, and I have to be careful when I put this down, I'm saying perimeter of rectangle, although we're not going to include this side of the rectangle. Remember, we just want the distance around the whole thing. So I'm putting perimeter of rectangle, even though I'm not really including that part, plus the perimeter of the semicircle. If I can add, and I probably don't need my units right now while I'm just doing the numbers, that perimeter altogether would equal 30. Okay, so let's start to plug in what we can. Perimeter of rectangle. If this side is y, that side is y. So to find the perimeter of the rectangle, or in particular, the part of the rectangle that I need, I'm going to be taking x plus y plus y. Now, I'm not going to write it like that. I'll probably write it as x plus 2y. So right now I have the perimeter of the part on bottom. Now I need to include the perimeter of the semicircle, and I'm going back to my formula here. I'm calling it perimeter, but perimeter and circumference are basically the same thing. Our formula said pi r. Now I'm not going to leave it as r. I'm actually going to plug in what the radius was. So we actually need to take pi times 1/2 x. And I mean, I'm going to write it as 1/2 pi x. I usually like to put the variable last. If you wrote it as 1/2 x pi, that's fine too. But I usually put the x at the end, and that is going to equal 30. All that work, and the only thing we've done so far is come up with our primary equation and our secondary. Any questions about how we got those? The good news is in your homework, you can reuse these, but the only thing that will change is that. Your perimeter may not be 30 feet in your homework. It'll probably be something different. So again, that's something that you can reuse. Now, going back to the steps from Friday, once you set up your equations, then you're going to take the secondary equation, solve it for one of the variables, and then plug that back into the primary equation. Now I'm out of room on this slide, so let me flip over to the next slide here. I'm just going to rewrite these so I can have them in front of me. xy plus 1/8 pi x squared equals max, and then x plus 2y plus 1/2 pi x, that would equal 30. Okay, before I solve this for a variable, I don't really like that fraction right there. I think that's going to cause some problems later on. So here's a little trick that I'm going to do. To get rid of this fraction, there's a 2 on bottom. So I'm just going to go through real quick and multiply everything by 2 just so I don't have to work with fractions. And that'll give me 2x plus 4y plus, now it's just a 1 pi x. I'm just writing pi x, and that equals 60. Okie doke. And to stay consistent with what I did last week, I'm going to try to solve this for y. And that actually probably is the easier variable to solve for. So subtract 2x, subtract pi x. Now it says 4y equals 60 minus 2x minus pi x. And so one more thing to do here to get y by itself, I'm just going to do it like that. Put everything over 4. And I guess it didn't help me out too much that I fixed my fractions earlier, because I'm going to run into fractions again right here. Instead of leaving it as one big fraction though, let's go ahead and break the fraction up into 3 pieces. So if you take the 60 divided by 4, that will give you a 15 minus 2x divided by 4. Well, 2/4 is going to reduce to 1/2 x. And for the last part, pi x over 4, I'm going to pull that fraction out right there too and just make it a negative 1/4 pi x. You don't really have to do that, but later on when I take the derivative, I guess it might be kind of helpful. Okay, that is just what y is. So we take this expression, wherever we see y in the primary equation, that is where we have to plug it in. Okay, so here I go. I'm going to be taking x times 15 minus 1/2 x minus 1/4 pi x. All of that was y. Okie doke. Then I still have a plus 1/8 pi x squared, and it equals a max. Not a bad idea to just go through and kind of check what you've written down so far. Got a lot going on up here, and you don't want to miss it just because of one wrong step. Now, I will have to take the derivative of this mess, but before I do that, it might be nice to go ahead and distribute the x out front. So it says 15x minus 1/2 x squared minus 1/4 pi x squared plus 1/8 pi x squared. That equals a max. Now, actually, looking through those terms, these are technically like terms. Pi x squared. You could combine those if you want. I didn't really do that. I'm going to go ahead and just take the derivative of each term separately. Okay, I hope you're with me. On a test or a quiz, this problem, if there's one on there, it would be worth lots of points because it's a good one. Derivative of 15x is 15. Second term, pull the 2 out front. The 2 and the 1/2 kind of cancel out, and that's just a negative x to the first power. Right here, let's work on the numbers first. 2 times 1/4 is 1/2. Now, remember, pi is just a number, so I'm going to leave pi alone. And then now x is to the 1 less power. So now it's just minus 1/2 pi x plus, pull the 2 out front. 2 times 1/8 would be 2/8, but that will reduce to 1/4 pi x to the 1 less power. And derivative of a max, I don't know what it is, but I know it's a constant, so derivative of that would just be 0. Okay, now, last couple steps here are gonna be, and I've almost forgotten what I'm even trying to do, I'm trying to solve this for x. At this point, I should be able to get x by itself. Now, these 3 terms right here all have an x. So I may kind of move that 15 over, and I'll have a negative x minus 1/2 pi x plus 1/4 pi x, and it equals negative 15. I just subtracted the 15 over. That way, I wouldn't have to worry about it because it doesn't have an x. Now, I know this is fairly complicated right here, but if I'm trying to get x by itself and all 3 of these terms have x, anybody know what I could do with the x? Yes, I like your sound back there. Yes, whoosh. We're going to pull the x out front, basically factor out an x, and then you'll only have it 1 time in the problem instead of 3. Now, I ran out of room here again, so I'm going to have to do the old switcheroo. On to the next slide, I'm going to take what I have right here and factor out an x. Okay, so here we go. I'm going to go back and forth a little bit. Pull an x out. So this is now negative 1 minus 1/2 pi, going back here, I pulled an x out of that, plus 1/4 pi, and again, you could actually combine those because technically they are like terms, and it equals a negative 15. So to get x by itself, I need to go through and divide everything by -1 minus 1/2 pi plus 1/4 pi. That seems weird, but all of those numbers, all of these terms on bottom are numbers. I don't know what they are, but I'm going to find out. And actually, before I try to do too much on my calculator, let me just do one thing at a time. I'm going to leave that -1 there for a second. Now, taking 1/2 times pi, I mean, it's just pi divided by 2. That is approximately a 1.57. You can go ahead and do that if you want. That's about what this term is. Then I need to add 1/4 pi. So I'm just typing in 1/4 times pi, or really you could just do pi divided by 4. And that is approximately a 0.79. Now again, I'm doing these steps because I don't like to do too much on my calculator, especially when there's a fraction involved. So at this point, I'm just typing that part in. -1 minus 1.57 plus 0.79, and that is a -1.78. So finally, take -15 divided by that number, and I didn't really put what to round to, but I would say 1 or 2 decimal places is fine. I got an 8.43. That is the length here, and I think they gave us feet. So we do probably need to label that 8.43 feet. That is X, bless you. Now to find out what Y is, remember you needed length and width of that rectangle. So to find Y, I'm going to reverse here, and I'll probably use this to find Y. So wherever I see X right here, I'm going to replace it with 8.43, and I'm just typing this in. 15 minus 1/2 times 8.43 minus 1/4, and I'm doing decimals here because it's easier, 1/4 pi times 8.43, and that is about a 4.16. Depending on how you round, or even depending on when you round, your answer could be slightly different, but 4.16 feet. That was the width, and then the 8.43 is the length. Alrighty, any questions about that one? Okay, promised her, I told you it was going to be long. Again, the good news is, well actually here's the good news. I even think I marked that one out. So why don't we just do from page 263, number 21. And that is it.